it's very interesting to observe the different attitude to these things in Europe compared to the U.S. And I think we definitely, we in Europe have something to learn from you because you are, you use maize in Europe, we use a lot of wheat. So it's an easy job for us to produce a good pellet quality. So we produce a good pellet quality, but it costs a lot of money because you need to reduce the throughput and all these things. So I think what we can learn from you is actually to lower our shoulders a little bit on what we require in terms of durability. And also it's interesting to observe that your philosophy of where you spend your energy in the feed mill is actually different from in Europe.
Hello and welcome to the Feed Science Podcast. My name is Adam Farrenholz, and I'm here at North Carolina State University in the Prestige Department of Poultry Science and representing our feed mill program here at the university. I'm joined today by a researcher from the other side of the Atlantic Ocean. I'm going to try real hard with the name here, and then I'll let him introduce himself and correct me on my pronunciation. Our guest today is Birger, or Birger, is, as he said, we would tend to say in America, Svihus. And Birger is with the Norwegian University of Life Science in Norway. So with that, I will let you go and introduce yourself, and then we'll have a bit of conversation about feed milling.
Great. Thank you very much, Adam. It's great being here. Feed technology is really something I've been working a lot with, actually, since I finished my PhD in poultry nutrition in 1997. And actually, that was the year where we built a experimental feed factory at my university, Norwegian University of Life Sciences. So I've been kind of involved in feed technology, primarily related to poultry, I have to say. But I think that some of the things that we've learned is applicable also across animal species. And I've also been responsible and taught a lot in the master course we've had in feed technology. So teaching the general topics of feed technology. So it's great to be here to talk about a very nice and very interesting topic where really there is, there's a lot of exciting opportunities, I would say, to take the science even further.
Yeah, I agree. It's always really interesting to me as we do research, and we look at what's being done here in the United States, and then we look and see what's being done in other parts of the world, and especially what you guys are doing there in Europe, and seeing where things where they kind of come together, and we're working on similar things, and then things, because of our processes being different in some ways, and in some of the goals and the ingredients being used and everything else, and where we've gone off in different directions. I think that's always something that's really interesting to see. And when we go and look at the literature or whatnot, see where some of those similarities and some of those differences are.
Exactly, because when I started, I think that I started teaching, I was taking responsibility for this master course in feed technology in 2003. And when I started, I was trying to, read the literature because it was a new field to me too. And I realized that, as opposed to, for example, poultry nutrition, it's not really, there's not an enormous amount of research. The amount of research and research-based knowledge was not as large, at least, as in many other disciplines. So I had a lot of, I enjoyed very much to read this American book. And I'm sorry, I don't remember the name of the authors, but it was this feed technology, the 5 volumes or even 6, I don't remember, the big bricks of information that I read. I don't think I read it all, but I learned a lot from those books, at least. But even with those books, I still felt like I was. I still felt it a big challenge to teach feed technology because of a lot of things was difficult to document, or it wasn't. It was a lot of experience-based knowledge, right? So there wasn't really any data behind the assumptions, I would say. But since then, of course, there has been a lot of research, and it's getting better and better. And that's exactly what we're going to talk about today, isn't it?
Yep. Yeah. So you're referring there to the feed manufacturing technology. I think you're right. I think the bound version, we ended up at 5, and I think that was published in like 2005. And the first one, which wasn't called Feed Manufacturing Technology 1, it was just Feed Manufacturing Technology. I don't think they knew they were going to make 4 more. And I think that one was in the late 70s, 76 or something like that. Now it's gone somewhat digital. That's been one of the projects been worked on over here. But as you said, there's just all this information, and it's the feed milling becomes interesting, right, from the research side, because we play this game of, we hear all the time, is it an art or is it a science, and is it a little bit of both? And I always kind of refer to it as, it's the parts that are an art are still an art because we haven't figured out the science yet.
Exactly.
I can feel things in my feet, or I can hear them, and that means that I know there's something to change or something to do, and we just haven't measured it yet, right?
Exactly. A lot of it depends on experience, and as you say, it becomes an art, and therefore I think it's so important that academics like us, we need to be out there, get dirty in the feed factories, and talk with the people that work there, learn from them, and vice versa. Because if we want to try to convince them of doing something, we need to be able to communicate with them also, and listen to them also. So it's kind of, I think that really when it's really getting interesting and fruitful is when we manage to find a way of communicating, and we have respect for each other's theoretical and practical competence, and together are able to take things further.
Yeah.
So I really think there is room for adjustments and optimization in the feed processing. So I mean, as you know, I've lately been working a lot with in fact, a lot of the work I've done related to feed technology has really been about structure, about diet structure. I mean, that has been my thing. And I mean, they really realize how narrow science is, but that has been my research. It's been a lot about structure and a lot about poultry, and particularly broilers.
So when you say, for those in the audience that might not quite understand what you mean, when you say structure, what are you referring to when you say the differences in structure in feed?
Yeah, and that is actually where I have to start, because I think that structure, I mean, I usually say that structure mainly is 2 things, and I divide structure when we have a pelleted diet, at least, or a shaped particle like a pellet or even an extruded particle. The structure of the diet has kind of 2 levels, I usually say, although you can even say it's 3. But the macrostructure is really the particle size and the particle distribution of the pelleted material, right? Which includes of course, the diameter of the pellet, the length of the pellet, but also the unavoidable abrasion and breakage of the pellet into smaller particles. So you have the fines, and the partly broken down pellet particles. That is kind of all I call that macrostructure, because that's the structure as you can see it. But for the animal, that's not the structure. I mean, it's the structure that animal also sees. So it's very important, for example, for feed intake. It's important for, homogeneous mixture and feed spillage and all these things. But then once the feed has been eaten and the pellet dissolves, and we know that it dissolves quite quickly, and then there's another level of structure which has been shown to be extremely important in poultry, and I call that the microstructure. which is the particle size and distribution of particles that the pellet is composed of. So there you will, that particle shape, that particle distribution will be affected by, the grinding types, the seed screen size, whether you use a hand mill or roller mill and all these things. And of course, the grinding taking place in the pellet press. But that is then the microstructure. So those two things, I think it's very important, as you say, that we stress what type of structure we're talking about, at least for these two, because they are very different in what they do to the value of the feed, or to the value for the animal and the farmer.
Yeah. So, it's interesting when we think, again, as you think about that macro structure, and when people look at the feed, and especially in a pelleted feed or a crumbled feed, or as you said, even if it was an extrudate, they look at it and they think, okay, that's what the animal consumes. But as you said, in any animal, there's going to be some sort of breakdown. And in a monogastric, they're going to chew it. Swine are going to chew it up. Or in poultry, obviously, the gizzard's going to take it. We know what the gizzard can do. The gizzard can take a whole seed and break it down into nothing. So really, within a few seconds of that pellet being consumed, what that pellet looked like on the macro side is probably somewhat irrelevant. But at the same time, and you just mentioned something there, I wanted to ask you to talk a little bit more about, when we think about, okay, then after the let's say, let's use the chicken in this case, after that broiler has consumed it, now it's broken back down into what I know it was before based on how it was ground. But what are we missing there with that idea of, well, we know how it was ground coming out of the roller mill and the pellet mill, or out of the roller mill or the hammer mill, but what may have happened in the hammer mill that we don't actually necessarily know the exact distribution, because there's been another processing step that we haven't always thought about as being, quote, grinding, but almost certainly there is some.
Exactly. Yeah. So what I mean for the microstructure, I think that I know that I've been able to convince Norwegian for feed producers to do this, and I think it is growing interest to actually try to determine the microstructure of the diet by simple in principle, but not simple in praxis, but to just dissolve the pellet and measure the particle distribution of the dissolved pellet. We use wet sieving procedure, and that's also what the feed industry is using in Norway. It's a laborious procedure because you need to wash the dissolved pellet through a series of sieves. So it's kind of similar to the dry sieving, just that you need to wash it through. And then, when you're finished washing it through, and then there's the issue of flow and speed of water and all the things that you need to standardize to have a good standardized measurement. But then when you've done that, it's a wet material. So you need also to dry it to get the particle, the dry matter particle distribution, which is what you want to know about, because you can't know if the water content is the same in all particle sizes. So it's, it takes time, it's laborious, but what I usually recommend, if you don't have the equipment, you don't have the equipment, and if there's nowhere to send it to get this done, and this of course is difficult. But if you have the equipment, you can't do it like as often as you do with, for example, pellet durability tests. But at least I would say do it for your standard diet with your standard pellet press and your standard grinding procedure, at least so you know where you are. Because as you say, it's not only about, if you use a hand mill, it's not only about using that or that screen, and then you know what the particle size of the pellets are. It's more complicated than that, because it's there's a lot of factors in the hammer mill and size of hand mill, speed, all these things that will determine the grinding result, and then you have the pelleting process.
Yeah. When you started kind of going through that process, what did it look like as far as, you mentioned, I kind of saw you chuckle when you said it, you've convinced the folks in Norway at least to start thinking along those terms. What did that process look like, trying to convince the industry to take on potentially another analytical test, another quality assurance measure. And boy, this one sounds complicated. Why do we do it? What did that conversation look like?
Well, I mean, the most important thing is you have to convince them that it matters. I mean, that it matters for the economy and production, right? I mean, that it matters for the birds. I talk birds because it's birds I mainly work with, but so you need to convince them this is important, and that in poultry, I think that it is now. I mean, the industry at large is, to a large extent, convinced that it is important with some coarse particles in the pellet, actually to stimulate the gizzard. Um, and there's been so many publications in this area now, and it's been demonstrated again and again and again. The only question now is not whether it is important. We know it is important with some structural material in the diet. The question is rather how much and what the size should be, and what. And another important issue is how much do they compensate for lack of structure in the diet by eating, for example, litter. We know they eat litter, and we know they actually eat more litter when there's less structure in the diet. So all these things, I mean, the practicalities of defining exactly where you should be is not that easy. And that is exactly what I have a project now together with the feed company in Norway, but it's still a research project, an applied research project. And we really try to now figure out what the structure should be, both from a bird perspective, from a stimulating gizzard, maximizing digestibility, and therefore feed efficiency as good as possible. But also from a feed technological point of view, because grinding coarsely saves you energy, and this is Europe been an extremely hot topic the last year or two. But it's of course important, whatever the cost of energy is, because our low energy consumption is a very important success criteria for economic feed production. So we think that if you don't need to grind finely, you shouldn't. Even if there's no benefit, of grinding. Even if there's no benefit, of course, grinding. Obviously, if there's no benefit of fine grinding, you should not fine grind because it costs money. Right? It's as simple as that. So we are. I can tell you. I don't know. I'm just talking, but I think that for poultry, this is all about stimulating the gizzard. This is the stomach of the birds, and it's important that there's feed has a retention time there, so the hydrochloric acid, the pepsin can have time to work. And when the gizzard is well functioning, it's also an extremely efficient grinder, a wet grinder producing extremely small particles, actually average size of maybe 100 microns of the particles that pass from the gizzard into the duodenum. But it needs to be stimulated to work like that. And I think that if we want to do that with the feed, and particularly if we don't have fibrous cereals in the diet, because that also matters. If you use barley or oats, for example, the hulls in those cereals will do a lot of that job, stimulating the gizzard to grind, and then you don't need to particularly worry about that you're grinding too finely. So, but if you use a maize diet, and which is, after all, it's the king of poultry diets, at least, or broiler diets, you should try to have a significant amount of particles, maize particles larger than 2 millimeter in the pellet.
And that's kind of that big trick, right? And you mentioned it before of everybody now wants to know, okay, we know that it works. We know that the larger the particle size, we stimulate the gizzard. We've learned that, as you said. Now, how much and under what distribution? I think it's one of the really interesting things actually that's happened on discussion with particle size, in that, so when I was in school, when we were first taught about particle size, we were taught about it from an actual, like a milling perspective, flour milling. We were looking at the history of flour milling. They used to have what was just called the modulus of uniformity. It was fine, it was medium, it was coarse. And then over time, as the different methods developed, and obviously we've been using sieving as some manner of a method, and it's gotten better and better. And more or less, it's been kind of the same now for a number of decades, as far as taking a sieve stack and creating a number. And we get this DGW number, this geometric mean diameter. Or if you really want to spend the money, you can run it through an actual visual testing and, actually get an absolute knowledge. But on that sieve test, we've always talked about, what's the DGW? And especially on the broiler side, it seems like we're kind of actually going back in time to, maybe I'm not as concerned as much about exactly what and how you're going to get to that average particle size, because, as someone who's researched this and played around with it, you tell me you want 800 microns. Well, I can give you 30 different samples that will all end up coming out as 800 microns. That doesn't tell you enough if you don't actually know what the distribution is, and not just the SGW number, but what's the percentage above it this size and what's the percentage below this size. And then working with the feed mill, especially in a situation where maybe all their grinding is for broilers. If they're also grinding for some layers or some breeders and they're grinding coarsely, maybe they've got a stream over there they can use. Or if they're using hulls and oats and things like that, maybe there's some fiber and some large particles over there. But man, if you're just hammer mill grinding fine corn as fast as you can to feed 800 micron, 900 micron particle size to broilers in these large integrated facilities, and then I say, well, I'd like to see a wider distribution. It's like, well, we've designed all the equipment to not do that. Where do we go? Where do we go now? So it's kind of fun to watch everybody almost have to go back in time and think about it in a different way, I think.
Yeah, because I think that personally, I like to see the distribution of particles in a sample, and you can get that. You can actually, you can even say it's even simpler to make the particle distribution than to make this complex use of complex equation to calculate the mean retention, mean particle size, geometric particle size. Sorry, because I really, as we talked about now, I think that I usually say, I try to, it's like if I have a gun to my head and I have to give common recommendation, my recommendation would be maybe 20% of the particles should be larger than 2 millimeter in the pellet. But I don't know if it's right. But you have to say something, and it seems to at least I can say that when we have been running experiments with microstructure measured, determined by wet sieving, we figured out we have 40% particles larger than 1 millimeter in the final diet in the pellet, right? And of those, half are larger than 2 millimeter. We know that the broiler chicken, fast-growing broiler chicken, will perfectly be able to handle it. So at least we know that. So that's. But I also have seen, we've done experiment where we've been going quite high on coarse particles, for example, using whole wheat and so forth. And there is a pain limit. So that's why I say this is not the pain limit. But the pain limit is if you get too much coarse particles. Because it's also a fact, that the fines, they are the ones that cost money in the grinding process, right? The coarse 2 millimeter particles cost almost no energy at all. But it's the fines, the small particles that kind of goes around and don't get out of the hammer mill. Those are the ones that reduce your throughput and increases the energy consumption and makes the ground material hot, right? So therefore, I think that equally important is to avoid a lot of very fine particles. So that's on the end of the scale, right? But of course, I don't know if you should kind of have. I think there should be a distribution. We shouldn't have like all the particles should be 1 millimeter, for example, because I think that you need a mix of smaller and larger particles to glue this thing together to a pellet. But how much fines you need, I don't know. I think we don't need as much as we often have. That's my hypothesis, I would say.
I was going to say, what have you guys seen as you looked at this? And we've seen some things here, but I'm curious on your perspective, especially since your processes and your ingredient forms are different than we often see in a U.S.-based diet. We always used to, and I remember very well when we really started looking at this coarse particle stuff was right when I was about in my master's, so kind of that mid first decade of the 2000s. So and that's when it really started ramping up.
Yeah.
And the big concern was, but large particles, you're going to kill your pellet quality. They're going to fall apart. You're going to have fines. And I don't know that it's exactly turned out that way. How have you guys seen that? And what have we learned about that, you think?
Exactly. No, I think that, I've been trying to go through the literature. I mean, there has been quite a few papers published where they have manipulated the particle size to made a pellet after a more coarse grinding, for example, in a hammer mill. And I was surprised when I did that literature review, when I realized that, in fact, in very many cases, you don't see any reduction in pellet durability, even if you produce if you pellet a much coarser material. Sometimes you do, sometimes not. So at least my view is that it's not as critical as we tend to think. I think it's been overemphasized that we should grind very finely in order to be able to produce a good pellet. And also, I think that durability. That's another one of my things that I'm interested in. I think the way we define fines is also something we need to look at. I mean, remember the old rule of thumb, has, at least for the Holman test, has been that the sieve that will determine when the pellets have been disintegrated, right, should be 80% of the diameter of the pellet, for example. That has been a rule of thumb, but very often, I think we use a 2 millimeter sieve to kind of define everything smaller than 2 millimeter as fines, and then we have to kind of ask the animal, the bird, what is fine for the birds. I mean, what is fine? What is these fines that they don't like to eat? And I think that a 2 millimeter pellet is not fines in the eyes of a broiler chicken, for example. And also I think that when we have a coarser grind, we have to remember that we have a smaller amount of fines to start with, right? So when if the pellet breaks apart, and even if it's abrases, on the ends, I mean, the particles will not be as fine because they're coarse to start with, right? So, I mean, I think that there can be something there. And we actually, this project I'm running right now, we are trying to we've been running some experiments. We actually tried to make a very poor pellet quality. I know you guys in the U.S. have done a lot of one beautiful paper work on this, which I've really enjoyed reading from West Virginia, for example, and also several universities in the U.S. That have done that, and you see that the tolerance for these fines is also perhaps not as dramatic. I mean, it's not as bad as we tend to think. We try to reach like a pellet durability of 90, but when we have been running experiments with diets with pellet durability of 70, we haven't seen any difference in feed intake compared to a 90. So, and again, this is also about cost in the feed mill, right? Because the pelleting process, I mean, the energy we have to spend to glue these particles together, particularly if we want to reach 90 as a pellet durability. I mean, we need to use lots of steam, right? And we maybe have to reduce the feeder rate. We have to use dies that are thicker, for example. All these things is extremely costly in terms of energy, right? It's the most costly part of the whole process, of course. Maybe 50% of the cost. So even there, my thinking is that we shouldn't make the pellet better than what the body animals desire or require.
Yep. And there's some really interesting, as you mentioned, there's been some really interesting data that's come out over the years, and in some cases, and of course, as it is in the case of a lot of things on the feed milling or the feed science standpoint, one of the tricks is there's so many variables at play at all times. There's almost nothing that seems to be this will work all of the time. There are a few things that we know that if we have a longer retention time of the conditioner, and if we get better these are good things. But there are other things where it's, this works very well in this feed mill. Well, it doesn't work in this one over here. Why? Well, slightly different systems, slightly different ingredients, whatever. But as you point out, there seems to maybe be some interesting plateaus in there as to where the animals get better. And so when people, and I talk to people and they'll ask the question, I'm sure you get asked all the time, kind of what's next in feed manufacturing. And I always kind of focus on two things. I say there will always be updates to equipment, but by and large, a hammer mill, a roller mill, a pellet mill, they're pretty well defined. We're going to get better at operating them. We're going to have new ways of controlling them, but it's going to be things that are related to collecting data, sensors, and things throughout the facility that we could never afford to do before. And now with Internet of Things and whatnot, we can do. And the other is going to be this idea of optimization. Because also, as you just pointed out, not only am I spending a lot of money potentially in the energy cost to make this better pellet, but think of all the other things I'm trying to put in the feed now: enzymes, probiotics, prebiotics. Well, they don't like friction, and they don't like temperature. And at what point did my better pellet end up making me have worse nutrition overall, and getting everybody to kind of get on that same page as far as actually chasing optimization, not just chasing that perfect pellet, which may not actually be in our best interest.
Exactly. I think that I was visiting Alabama in May, and hosted by the great colleague of us in feed technology, Wilmer Pacheco, and also with Samuel Wachell at Auburn University. They were very friendly, and they were showing us around at their university, and also we visited feed plants and broiler facilities. And I knew this from before, but I just wanted to see it. It's very interesting to observe the different attitude to these things in Europe compared to the U.S. And I think we definitely, we in Europe have something to learn from you, because you use maize in Europe. We use a lot of wheat, so it's an easy job for us to produce a good pellet quality. So we produce a good pellet quality, but it costs a lot of money because you need to reduce the throughput and all these things. So I think what we can learn from you is actually to lower our shoulders a little bit on what we require in terms of durability. And also it's interesting to observe that your philosophy of where you spend your energy in the feed mill is actually different from in Europe. In Europe, as far as I know, and I think I know, but I can be wrong, there can be exceptions, but in Europe, they use thick dies with a diameter to length ratio of 1 to 18 or 17, 1 to 17, 1 to 18. So, and they use 3 millimeter pellets often. So, They're thin and they're long holes, and it's a wheat-based diet, so you really need to use a lot of energy to push these things through the die. But what they do is they use a low conditioning temperature, maybe just 75 degrees. So the temperature increases in the pelleting process to 85. In the US, it's the opposite. You condition, at least from my experience and what I've been told, you maybe get up to 88 or something like that in conditioning temperature, and you use a thin die, and there's no temperature increase in the pelleting process. I wonder who is right. I mean, and actually, as always, maybe the truth is somewhere in between. But I think definitely, in Europe we are using too thick dies. I think that and you know it. So that is one of the things we have been looking into, and we will continue to look into, to use a thinner die, maybe get down to 1:12. I mean, which is still maybe around where you are, guys, but and then increase the conditioning temperature somewhat, and see if we maybe can save energy in the processing by doing that and increasing capacity and having the same durability.
Yeah. It reminds me of, I took a trip. I was doing some work up in Canada, and it was in a swine feed mill in Canada, and they were having trouble with a specific medication, and it was an antibiotic, and it wasn't a chemical antibiotic, so it was going to be maybe a little more affected by processing, although generally we don't see a huge amount of impact there like we might with an enzyme or something. And we were in a mill, and they said, so they're really having some trouble, and it's in there after the mixer, but after the pellet mill, it's just not there. And said, well, let's go take a look. And I found very quickly that they were running an expander. So they were running a decent conditioning temperature. They were running an expander, and then they were still running it through a die that was, like you said, it was about an 18-1. And I thought to myself, I'm surprised anything that's thermolabile is living through this. I mean, it's just the amount of just absolute, pressure and temperature. But on the flip side, as you say, when we look at it here, one of the ways that I've always thought the optimization question is interesting is, let's say, across the broiler companies in the U.S., we've always had some that really focus on something like pellet quality and not having fines, and they will run a thicker die to an extent if they need to, not to the European specifications, but much more than others. And then we'll have others that, if it went through the pellet mill, it counts as pelleted feed, good enough. And you know what? Both of these companies are profitable,
Exactly.
and so that really tells you, no, there is not one right way to do this, or to your point, if there is a right way, it's probably somewhere in between those two, and trying to find. I think that's going to be our challenge over the next, however long we try to chase it, is figuring out, especially on this grinding, pelleting ingredient, what's optimum and how do we define optimum, and then get everybody to understand that optimum for you does not mean optimum to you, and your equation is going to be different than yours because you formulate different, or your equipment is older, or whatever the case may be.
Exactly. As always, it's a compromise of conflicting interests, and even if you have a very poor pellet quality and you have, as a consequence of that, slightly slower growth, it may still be may still be the best solution. For example, since it will perhaps reduce mortality in the flock because they're growing a little bit more slowly, and you save energy and effort in the pelleting process, so that you don't spend so much energy there. So it can be the right thing, but if you in other situations, labor is expensive, houses are expensive. For example, you need to utilize the houses more efficiently, and there's not a mortality issue, then maybe it will pay off to produce a better pellet quality. It's all is a matter of doing the math, right?
Yeah.
And that also leads me to something very important when you say what is the future. The future is more data, as you say.
Yeah.
with data of the process. When I'm working with this company now, they're very good people. They're really interested. They're willing to make changes. They are very much into this. But I'm surprised by that they're not logging, for example, the energy consumption from the different parts of the process. I mean, what we should do is, for example, to have all these data real time, all the time, so we could connect, for example, durability to the energy consumption of the pellet press and whatever. I mean, the conditioner and all these things. And also when we're going to optimize these things, for example, when I'm now together with this feed company, I'm going to try to find a different process with, for example, an increased conditioning temperature and a thinner die. I need those data. We need to see how much energy, less energy are you using in the pelleting process and how much more are you using in the conditioning in order to figure out if this is energetically more effective way, right?
Yep.
So
Yep.
to data is, and they're coming because, everything now can be connected in a totally different way and be analyzed in a totally different way. So we have far more opportunities, and I think those that are quickest to grab those opportunities, they will gain a lot from that.
Yeah,
I mean,
I agree.
gathering and using it, and using it systematically, analyzing them, and look at connect that to physical quality of the pellet, and even to the performance. I mean, of the birds, right? So you have all these things connected, and you can realize where there is a bottleneck of where you can make savings.
Yeah, I think that using part of it is such a big deal from the standpoint. I always go in and look at, and I'd imagine it's the same in Europe. Most of the modern automation systems already have the ability, if the sensors and the things are there, to collect the data. But even on things that aren't sensors, there are all kinds of things with statistical process control that these systems can capture as to how optimized the system is, maybe just in efficiency, not even in energy or something like that. And the vast majority of people don't use that data, or the amount of times that they're, we're checking pellet durability, we're checking particle size. And what do you do with that? Well, it goes on this spreadsheet and it sits in this file, and we make sure that someone doesn't yell at me because it's out of spec. Well, but have you ever tied it back into this over here? Oh no, we're not doing any of that. So there's already a huge opportunity with the data we already have, much less what we could collect in some day. It's just convincing people to not only spend the money on, it's a pun not intended, it's that chicken or the egg of, we need to collect it, and we need to invest in the ability to collect it and analyzing it to see where it can, and someone's always going to want to know, well, can I make money off of that? And the answer is, well, I don't know yet. I imagine so, but I can't tell you yet until you actually give me the data to play with, right?
Yeah, the example I'm mentioning is one very concrete example where we actually need those data to actually answer the question. What is most energy efficient? To spend your energy in steam, or to spend your energy in running the engines in the pellet press? And then, of course, that is only the energy part of it. But then, of course, the effects on the diet and all these things is a different question. But it's interesting. I mean, another thing when we talk about, I talked about wet saving as something I think would be useful, at least in poultry feed production. Another thing that I am surprised that is not always measured is the post-pellet temperature. I mean, the temperature of the pellet immediately as it comes out of the pellet press. And I also, that's also what I always say, measure, again, not continuously, and it's difficult, and it's difficult to standardize this procedure. The simplest way it can be done, as long as you do the same all the time, it's okay. But for actually collecting a couple of kilo in a styrofoam box with a lid on and put a probe in through the styrofoam into the center of this and wait till the temperature stabilizes. If you do that, if you do it a standardized way, you will learn something that is very important. Whether temperatures increased during the pelleting process, whether it's stayed the same as the conditioning temperature, because conditioning temperature people usually have an idea about. But at the end result, and it's also very strongly connected to pellet durability in my experience. I mean, if you want high durability with one particular type of composition of the diet, I mean, it's been going to be very much linked to the post-pellet temperature.
Yep.
I mean, the higher that is, the higher the durability is.
Yeah, two PhD students ago, my PhD student, JT Pope, he did a bunch of work looking at thermostability of products as they move through, and not really any particular product, but just using various enzyme types as markers to test. And we found some really interesting data that really hadn't ever been looked at before of it really is all happening in the pellet die, right? Most of the conditioning absolutely plays a role. But if I collect a sample and coming out of the conditioner, I'll still have most of my heat labile, enzyme, probiotic, whatever. Most of it in most cases is still there. It's once it goes through that pellet die and it gets that hot under that much pressure that it's gone. And so it's really, okay, we've always just looked at, for a very long time, it's just some big piece of steel that not really much is happening. And I think that's probably been a mistake. I think there is a huge amount happening. My just finished PhD student, part of her work, she did a lot of that post-pellet temperature monitoring work, looking at the different methods of collecting it. And we have tried a few things to actually do it continuously. That's not, it's a very good experience for her as a PhD student, running the experiments and trying to find a way. We don't have a way yet. But it's been a fun experiment to try to find out, because it's just, I agree with you. I think it's potentially a lost data point that if we could figure out how to look at it, it could be just as important to try to set that as it could be to try to set conditioning temperature by changing a die or improving throughput or decreasing throughput or changing conditioning, whatever the case may be. Yeah.
I mean, the technical side of it is one thing, but as you say, the very close relationship between max temperature in the process and survivability of whatever enzymes or probiotics you're having in there is also a very important topic. And then the chemical changes to vitamins, for example, and all these things. So to keep an eye on what has been the max temperature, and particularly the temperature after the pelleting process, I think it's very important.
Yeah, I agree. I think we could. I'm sitting here thinking of some. I think it'd be very interesting at some point to get a group of folks together, if nothing else, to have a discussion about differences between the way feed is made in Europe and the way it's made in the U.S. and then potentially other parts of the country, other parts of the world rather as well. I think there are not very many people that do a significant amount in the feed mill specifically in that many different places. And I know when I've come over to Europe and spoken, I've run into other folks, and they kind of look at me funny with, well, that's not a very technical or advanced way of making feed. And then the U.S. side, we look at Europe and go, well, that's a very advanced and very technical, but you sure aren't making very much. Your production rates are very. I've had people come and ask me, so on when you're measuring pellet durability, so what are your normal pellet hardness? And I say, we have no idea. Nobody in this country measures that ever. And they look at me like, how can that be? We measure pellet hardness all the time. I think it's really interesting what those differences are and what we found valuable, and why we found things valuable, and then what's real there and maybe what's not between the two. There's probably a lot to learn there.
Yeah, well, I am. My hypothesis is that we are overdoing it in Europe. I mean, there is something called feet flicking. I don't know if you've heard about it in chickens, and I've seen it, and nobody really knows what it is. But it's I think, and many people think, but it's unfortunately it's one of those many things that people think, but nobody has even studied it systematically. But it's actually a too hard pellet. So the birds, and the birds, they don't want it. I mean, they are. It's simply too hard, particularly for rather young pellets, young broilers. It is simply too hard. You can see sometimes. The feed is almost like a glassy surface on the pellet, and that's a situation which sometimes happens in Europe because of this extreme focus on a pellet durability above 90. That there really shouldn't be any significant amount of fines in the feeder. So I think and the research that we've just recently carried out certainly confirms this. That we don't need to have this. It's a waste of energy, and in worst case, it's something that makes a lot of harm. I mean, one thing is feed flicking because it can be a big problem, and it, of course, reduces the feed efficiency, but also the enzyme efficacy and all these things that too high temperature can effect it can have on the nutritional quality of the feed is also a very big issue. But the other thing I wanted to, I mean, I don't know. I think we almost talked for an hour now, so you decide how much further we get. But I could just mention another thing because now we've been talking about both micro and macrostructure, which is basically what we've been talking about, and microstructure, the coarse grinding, and all these things, which saves money and is better for the digestive function of the birds. But the macrostructure, apart from the durability issue, we actually, the company that I'm working with, they have now switched to using a 5 mm diameter of the broiler pellets. And that's another thing that was a very big surprise for us when we actually carried out experiments to see what type of particles broilers prefer. And we realized that at least after 3 weeks of age, they prefer 5 mm pellet before smaller pellets. And that's another thing that, will save you a lot of energy in the pelleting process to use a bigger diameter. And it will also conserve the coarse particles in a better way. So that it will be less grinding in the pellet press. So we are now looking into to this issue of actually using switch to a 5 mm pellet. I know there's another difference between the U.S. and Europe. Europe is very common. Most common is 3 or 3.5 mm pellet for broilers. The U.S. it's more common with 4, even 4.5. So we've taken your principle, but even further, going up to 5 mm.
Yeah, it's interesting from the perspective of, and I know exactly where you're coming from the idea of, you would think as long as we have been making feed and pelleted feed certainly someone has done lots and lots of research on all the different pellet diameters and how they affect, and then you go try to find it and you find out, actually, no, we've really not done that work. There's a few things here and there, but nothing that you can bring together and have a full picture. It doesn't exist.
Exactly. And then, there is some literature, and I think I've managed to find it all, and it's very good literature. I mean, solid experiments and so forth. But first of all, it's like in the 80s, for example, the broiler chicken was different in the 80s than it is now. And secondly, there's always ways. I mean, it's always the ways you do experiments and what particle sizes you actually used. So in fact, this is my experience that nobody really knows what the preference of the birds is in terms of particle size. At least we don't know. Well, we don't even know the preference. I mean, there's far too few preference experiments carried out, which they're not very complicated to carry out. I mean, they're not very costly either. So it's just that people have assumed that, that it's been like a tradition almost. Like, okay, we use 3 mm, and then they stick to it. But it's also costing a lot of money to use a very thin hole in the dye, right? So we have been doing a lot of experiments. We actually even did a 5 millimeter pellet on was it 5 or 6 day old broiler chickens, and we 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 gave them it was like a row of different compartments, 4 different compartments with different particle sizes, larger than 4.75, and then what was it, 4.75 to 2.8, 2.8 to 1.6, and below 1.6, and 5 or 6, I don't remember, day-old chickens. They still, they ate less of the 5 millimeter pellets, but maybe 20% less, but still they ate a lot of it. It's not like they can't eat it. So there's also a very big surprise that they really seem to prefer larger particles, or at least be able to handle larger particles than we thought. So that is a simple thing, really, and very basic thing. But we have to remember, this is why we pellet. We pellet to facilitate feed intake. And so definitely we need to look into which particle size the whatever animal we're dealing with, but in birds particularly important, because they pick one and one. So we need to definitely in poultry nutrition learn about what type of particles they prefer and what type of particles they can handle. Even if they don't prefer them.
Yeah, and as you mentioned, that's all. Those are all things then that end up helping out the feed mill in some way too, right? Where it's hey, the birds can take this, and by the way, I just saved you 10% energy cost.
Yeah.
And I made your dye last. I made your dye last another 100,000 tons or something, because it's got nowhere near the amount of back pressure and friction that it had before, and how all those things just add up. Yeah.
They're so happy now, the feed mill, they've switched to 5 millimeter pellets, as I told you. And the managers of feed mill is, I'm the hero, because it's so much easier to get the feed through a 5 millimeter dye than a 3 millimeter dye or a 4 millimeter dye. And we even made pellets. We wanted to test this idea that they could handle 5 millimeter diameter pellets. We made them, the one that we thought we would be able to use was a 5 millimeter diameter, 6 millimeter long pellet. Because we measured these things and we were able to produce this, and the same durability between the diets. But to see where the pain limit was, we also produced a 5 millimeter pellet that was 10 millimeter long. So, and it's really a big chunk of feed. And we fed this to broilers from 10 days of age. And, we just included that to see that there is actually a limit. But in fact, no effect. They grew exactly like they did with the 3 millimeter pellet and a 5 millimeter pellet with 6 millimeter length. They actually were able to cope with it, which was another big surprise. And we had, this diet was a high durability pellet with very little fine, so it wasn't like they could just avoid to eat the large particles. They had to eat large particles, and they did from 10 days of age. Amazing.
All stuff that people would have, said, no, they can't. They'll choke. They'll, the gizzard will get impacted.
Yeah, we said that too.
It won't work. Yeah.
So
absolutely.
It was really interesting. But I think that, in this, when you start thinking about these things, you realize that, hey, wait a moment, a 10-day-old broiler chicken, is much more active than a 30 days old broiler chicken. So it can stand up, it can eat longer, it has the will, the desire to eat longer, and also, there's more space around the feeders. That's at space. There's all these also management things that you need to start thinking about. And then you realize the 10-day-old broiler, there's no limitation of space. It can stand for longer. So even if it uses more time, and we showed that it actually was using more time eating, we also measured that. But it doesn't matter because it has the time to eat more. And so it can do it. But when it gets to 30 days of age, they are heavy. They don't want to stand up for a long time. So, and there is a limitation for space. So then it's a different question. So, and we think this is the explanation that it works so well.
Interesting.
It's time for our famous three.
Well, Birger, I think you and I could probably talk about feed milling and feeding for forever. And honestly, I think we need. Yeah, I think
Not
we do.
today.
I think we need to set up some opportunities for some of us to get together and, like I said, talk about what's the same and what's not, and where's the data missing and all that sort of thing. But I'm not sure if everybody else wants to hear all those conversations or not. Maybe we'll record them for them, and maybe we won't. Keep some of the secrets to ourselves. But before we finish it out, the few questions. So these series of podcasts have one of the things on the poultry and on the swine side that have become a part of it is always asking kind of a series of questions there at the end of getting things that might be beneficial to folks. So the first question is, do you have a resource on the feed side, feed milling, nutrition, whatever it might be, that is a book or a resource, something that you found incredibly valuable that you would want to make sure that others would know about as they're wanting to learn about this particular realm?
Well, I already mentioned this classical work from the U.S., this big series of the handbook, Feed Technology Handbook, which has been useful. But it's been some years since it's been updated. And actually, there is a lack of good literature. I am actually writing a couple of chapters in a book that's supposed to come out soon. That is an initiative from Wageningen University. Hopefully that will be a good book, but it isn't finished yet. There's also a pelleting handbook that the Holman, the company that produced the Holman durability, it's also useful. Apart from that, I don't have so many good recommendations on this.
I agree. That's finding those. I think in our world on the feed side, resources end up being really heavily skewed towards people and a lot less towards literature. I think that's just kind of, we learn a lot from others in a lot of ways, and then go get the technical works and things where they are, but a lot of the rest of it is kind of learned by word of mouth, at least for now. The next question would be, how about outside of that realm of feed milling or nutrition, things related to management or leadership or anything that you found really interesting that you think would be really great if everybody read this or went and watched that or something along those lines?
Well, to me, I mean, I'm an academic, first of all, and what I really think that is extremely important is to keep an eye on the scientific publications in the area of feed technology. Where I use, with my area of mainly focusing on poultry nutrition and feed technology, there I find that the Journal of Applied Poultry Research is run by the Poultry Science Association. It's a really good journal. They publish a lot of very good work on feed technology related things, poultry nutrition. That would be my main source of information. Of course, attending conferences and so forth. But when it comes to my kind of books, I don't really have. I don't really know of any particular source I would mention specifically related to this area. I mean, to relevance for the audience here.
Gotcha. So then the last question then is, what are some of the things that you found that as you go through kind of the world of feed milling, and it could be on the academic side and the research side. It's certainly also maybe just thinking about when you're out in the field and working with these companies, what are the characteristics that you find that set the most successful people that you run across? What is it that sets them apart, you think, from the others?
Well, I think willingness to try new things, or the ability to ask questions. To question things, and to be, like these critical questions. Why are we doing this? Can we do it better? And what about if we try this? I know it's difficult because most feed mills, they run 24/7, and the amount of feed they're producing is increasing all the time. So it's a very stressful situation. But those people that find the time to get on top of things and actually then start to look at how we can improve things, do things in a smarter way, more efficient way. That can, as we talked about the data, the importance of gathering data and analyzing data. Those who have the curiosity and the mind to try to look into these things and do it better. I think that is a very important success factor. Of course, competence among the people that run the feed plant is important, but just as important is the interest in actually trying to do things better. And I think that those who have this or do this, they are much rewarded for. It makes their work interesting, right? It is rewarding to do improvements that will benefit all.
I agree 100%. I think that curiosity is a huge part. I say all the time when I go into facilities and I'll find maybe a pellet mill operator that likes to play with their machine, and this person wants to see if they can make it run faster or make it run better. And I'll tell their management every time, don't ever let that person go, because instead of just being here to make feed, they're trying to figure out where the boundaries are, and they want to play with it. And that's so incredibly valuable, I think. And I think that's it's a great point.
That's how we move forward, right?
Yep, absolutely. Well, I have very much enjoyed our conversation. It will definitely not be our last. We will find other ways to have conversations in the future, whether it be part of a podcast or webinar or recording, or I'll find my way over there someday.
Surely we'll
sit around.
Find a time to meet.
So I've really enjoyed it. So thank you very much. My guest once again today on the Feed Mill podcast has been Dr. Svihus from the Norwegian University of Life Sciences. I'm Adam Fernholz with the Prestige Department of Poultry Science and the Feed Milling program here at NC State. Thanks a lot for joining us and hanging out for a little over an hour. I hope you all found that conversation as interesting and as enjoyable as I did. We'll see everybody the next time.